Video will make instantaneous centers which is defined for bodies having plane motion. Now to define this instantaneous center, we'll be saying the definition. The point, it is generally defined as a point common on two bodies or any two links which is under consideration, where the linear velocities of all the two bodies under consideration will be having equal magnitude. Now it's also defined as point on one body where the other body is assumed to rotate arbitrarily. Now this is called as the instantaneous center. Now this is nothing but point common to the two bodies where the other body is assumed to rotate with respect to the other body. Now in order to define the instantaneous center of various links or the bodies, we will be seeing how it is defined for each cases. Now the first case is we will have here two binary links here, link 2 and link 3. Now the link 2 and 3, they are connected at the point B here. Now this point B is defined as the instantaneous center between the two links 2 and 3 here. Now generally the instantaneous center is denoted by the alphabet I. Since we are considering the binary link 2 and 3, we will be writing the instantaneous center between these 2-3 links as I23. Now for this case, if two binary links are connected together, their point of connection or their intersection point is taken as the instantaneous center and denoted by I23. Now moving on to the next example, here we have the another example. There is nothing but we have a fixed link here and we have a binary link here. The link is named as 2 and the fixed link is numbered as 1 here. Now between this fixed link 1 and the binary link 2, say again the same thing, the point of intersection or the connecting point is taken as the instantaneous center. That is nothing but point about which where the other link is assumed to rotate at that moment. So this instantaneous center between link 1 and 2 is named as I12. So between a binary link and a fixed link, we will be naming the intersection point as the instantaneous center. Now if you consider this one, two rolling or rotating links here. Now this is the first link and this is the second link here. The point of intersection of the two links is assumed to be the instantaneous center between the two links, again named as I12. That is nothing but about this point. If you consider this point to be on the link 1, the second element or the second link will be rotating with respect to this point. Now next, let's learn the similar instantaneous center between different types of bodies here. Now let's assume this body. We have a sliding element here named as 2 that is sliding on the fixed platform or the fixed link 1 here. Now in such a case, the instantaneous center between 1 and 2 is taken at a perpendicular distance between two bodies at a distance infinity. Now this is the point instantaneous center will be taking between these two components. When the slider slides on a platform or a flat surface, its instantaneous center, that is nothing but its point of rotation or the center point of rotation will be assumed at a distance infinity, and it's taken perpendicular to the path of the slider here. That is nothing but the slider moving on a straight path here. Next we have a slider rotating or moving on a curved path here. Again the same thing. Now this instantaneous center between this curved path 1 and the slider 2 is assumed to be at the center of your curved path. Now this is the instantaneous center in this case. Next, moving on to the cam and follower type of elements here. Now this is the cam here and this is the follower here. Now the cam is represented by the element number 2 and the follower is represented by the element number 3. Now between this 2 and 3, the instantaneous center is located at a distance taken perpendicular to the point of intersection of the cam and follower. That is represented by I23. Now this is how the different instantaneous centers are taken. If this type of elements are given, we will be keeping this main things in mind and we will be solving the problems.